Yep.
Heat from mines.
A bit of both. Thank you. So good morning, everybody. I'm very aware that I do stand between you all and a cup of coffee, so I'll try and be brief. So I'm working at Durham University, and I've worked on abandoned mines since doing my PhD, more years ago than I care to admit. And I've been working on kind of treatment of metal mines and coal mines, and then in doing so realised that some of this water was warm, hence what I'm going to talk to you about today. This is a collaborative piece of work that we're doing with the Coal Authority and also an organisation called Lanchester Wines, and you'll see why shortly that we have the privilege of working with the wine distributor, which is always great. So as this event is all geared towards how geoscience can be used for decarbonisation, what I'm going to focus on today is how we can use geoscience to decarbonise heat specifically. So this will look at our kind of history very briefly of using coal, look at the energy mix we have in the UK today, see what progress we have made towards decarbonising energy, and look at how we can develop the legacy that's left by our abandoned mining infrastructure to provide a future energy source. I'll also tell you a little bit about how we've been doing this research, and I have a couple of case studies to show you where these types of systems are already operating. So in the UK, over the past century or so, over 15 billion tonnes of coal was extracted from the UK subsurface. And to put that into context, if I had that coal now and tipped it over the land surface of the UK, you'd be walking around on a layer of coal around about 5 centimetres deep. So it's not an insignificant amount of coal. And that's important because that equates to a void space that's left underground. And when you account for subsidence, we've estimated that there's around about 2 billion cubic metres of water, give or take a cubic metre or so, stored within the UK subsurface in our abandoned, flooded, deep coal mines. And when you think about the heat that's stored there, if you were to take 4 degrees out of that, there's around about 2.2 million gigawatt hours of heat in place. So it's a really vast resource. The UK's geothermal resources have enough heat to meet UK heat demand for a century, and this is one aspect of their geothermal potential that I'm focusing on in abandoned mines. The water that we see coming out of these systems, obviously they're not as deep as some of the systems that, for example, Roy was talking about. So he was working on low enthalpy. I wish I had the temperatures he has. I'm talking about ultra low enthalpy here. So we're talking about 10, 12, up to maybe 20, 25 degrees, depending whereabouts you are and how deep the mines are. Clearly, you wouldn't want to take a bath in something of that temperature, but we can use heat pumps to upgrade the temperature so it's more usable. And because it does come out of the ground at relatively low temperatures, we can also use it directly for cooling as well as boosting temperatures to provide heating. So it's very flexible. We also, in the abandoned mine workings that we have across the UK, we have a massive infrastructure that's storing heat at the moment, could be used to put more heat into and could be used to take heat out of. All it requires is commissioning. So it's there, it's ready, it's waiting to be used. And at the moment, the Coal Authority currently control the water levels within abandoned mines where pumps have been switched off. And they do this at strategic points across the UK. And the water that they pump out from those mines to keep water levels static equates to about 80 megawatts of heat that's just being kind of discharged to atmosphere. That's enough for around about 30,000 homes that's already coming out. We're not doing anything with it. So just to give you a bit of context for why I'm interested in looking at mine energy systems, if you look at the UK's energy mix, you'll see we still have a heavy reliance on fossil fuels, which is not surprising given what we've been talking about today. If you look at electricity, over the past decade or so, we've been quite effective in decarbonising electricity. So around about half of our electricity demand is decarbonised using a mixture of renewables and nuclear. But when you look for heat, you can see that the picture is very different. We're still heavily reliant on natural gas to provide our heat, and heat accounts for around about 3/4, or natural gas is making around about 3/4 of our heat provision. So we're still heavily reliant on fossil fuels here. Transport, the situation is even worse. That's why I don't work on transport, a very difficult problem. So also to put this into context, so I attend a lot of meetings and read a lot of kind of documents which are talking about future scenarios and talking about, you know, the plan for the future energy picture. And a lot of people, when they're talking about energy, when it comes down to it, they're talking about electricity. So I sit there and I'm a bit disappointed. Why won't somebody talk about heat? And the reason that I like to talk about heat is because when you put it next to the electricity demand, so on this chart, the blue line is the heat demand, the red line is the electricity demand. Heat demand is dwarfing electricity demand in terms of gigawatt hours that is required. And when you look at the kind of seasonal variation, you can see that the electricity demand, although there's kind of a daily fluctuation and there's also a seasonal change in demand, it's nowhere near as aggressive as the picture we see for gas. And it only takes the odd unforeseen events such as the beast for the east and our gas consumption effectively goes through the roof. So it's getting on to be orders of magnitude higher than our demand for electricity. And also the fact that when we want to look at heat demand, all we have is the gas consumption data. So we don't even monitor heat that well or know where and how it's being used and what are the extra sources that are available. So we have gas demand as a proxy for heat demand. So heat is really a poor relative and we need to give it a bit more attention. So one way of doing this is to turn to our coal mining heritage, and in order to consider this, we need to think about where our gas comes from. So I've shown you that round about 3/4 of our heat supply comes from natural gas. The UK has been a net importer of natural gas for over a decade now. And you can see that we're getting it from various sources. So apart from what we're producing ourselves, we are taking some from a European pipeline, which ultimately is controlled by other nations. So there's a question of energy security there associated with those supplies. And also we're getting 13% that's coming as liquefied natural gas via tankers. So although gas is posited as a lower carbon fuel, which it is when you compare it to things like coal, when you're looking at LNG, which has compression and transportation associated with it, then we have to think, well, how low carbon is it? Another thing we're doing is I really like the MyGrid app because I'm an energy geek and I quite like to have a look at this every so often and just check in with it and see what the UK is doing. It is quite often it's focused on electricity, but you can see here from this screenshot we had a day when we didn't burn any coal to produce electricity, and that was in the newspaper and we celebrated that. So we're now saying coal's a dirty fuel, we want to turn away from it, and we're celebrating when we're not burning it. A very different picture from going back maybe to the Industrial Revolution when coal was celebrated in terms of the wealth it could deliver and the advancements it could bring. But also, if you look at that screenshot, you'll see that we have very, very limited storage potential as well for gas. We have some of the lowest gas storage potential of our other counterparts in Europe. So we are facing an uncertain energy future. So this is what we have in terms of a legacy. The black areas on the map on the left show you where we have coal across the UK. And the map on the right shows you where heat demand is located. And there's quite a good overlap between areas of abandoned coal fields and areas of heat demand. And this is not surprising because some of our big towns and cities grew because of the coal that was beneath them. So we do have this good overlap. The only area that isn't served that well is where we're sat currently in London, but we think there's enough hot air down here anyway, so we don't need to worry about lack of coal fields. And joking aside, there are schemes here that use heat from the river, and there's also been studies done on taking heat out of the underground, and there's cooling at Green Park done using groundwater as well. So just to look at the county that I'm sat in, when I'm at the university in Durham, I had a student do some work on this, estimated that coal output for the county, which was quite difficult to find because some of the records are quite sketchy, and you have to make some estimations on the number of men that were employed in the pit, the number of coal, the amount of coal a man could hew per day, is how we work out some of these figures of coal output. They're not always recorded very well for every colliery. And in the Durham coalfield, we have 10,000 cubic metres pumped from places where the Coal Authority are controlling water levels. We have 0.4 billion cubic metres of water sitting in the flooded workings. And we reckon that the extractable heat that we could easily get from these mines could meet the demand of around about 12% of the homes in the county. So we're doing some work with our local authority and looking at areas of new build, looking at leisure centres and facilities that they're wanting to upgrade, seeing whether they correlate with abandoned mines and whether they can use them. Another reason to consider this technology is there's a lot of emphasis on decarbonising by using heat networks. So we're thinking about the compatibility of a mine water system with a heat network. It could be very compatible. You can, as long as you've got your resource and where you're planning to have your heat network, you can drill a borehole to target the workings and connect your heat network to a mine water system. The UK has an aspiration to have 14 to 43% of heat supplied by district heat networks by 2050. And at the moment, only 2% of our heat demand is supplied in this way. And I did some sums on this, just looking at current build rates and how we could do this, and we're not going to meet that target. So we need to do more in terms of integrating heat networks with all low carbon energy sources, and also look at mine water too. And the key thing that I'm promoting as well is when I'm talking about heat, I'm not talking about necessarily things that are hot. So we need to change our ideas about heat, which I'll talk about shortly. We were talking about lower temperatures here, so I told you the mine water may be on average around about 16 to 20 degrees, something like that. And that affects the design temperature. So for a lower temperature, you're going to maybe have bigger pipe sizes, or you're going to flow more water through the system to get the same amount of heat out of it. So people that are saying, oh yeah, we'll put a heat network in now and we'll switch it over to geothermal later, those are really important things to think about. Is it sized adequately to meet different temperature inputs? So the reasons why we should think about using mine energy, we're using it at Durham as a way to de-risk geothermal for the UK. Some of the problems with deep geothermal is that we know how hot it gets with depth, but we can't always guarantee the permeability. But we know these systems flowed water. Roy showed a slide before of a mine which was producing much water whilst it was worked, and we've got a lot of information about how coalfields were operated, and they're known to flow water. They're full of tunnels, they're full of voids, and they're full of water. It can be a low carbon resource, and as I've mentioned already, we can use it for heating and cooling. And possibly it does have a role in offsetting gas consumption for providing heat to save gas for more useful, higher value applications, maybe industrial processes. You don't need to transport the fuel, so if you're comparing it to an alternative such as biomass, you're not having to bring fuel to your heat network. It's continuous, so you can take or leave the heat as you wish. We've got opportunities for storing energy. And the system that I'll show you, one of the case studies, has delivered economic improvement for a region by keeping the money spent on energy within that region, rather than it going out to the equivalent of the big six or something. The cons are that there is some upfront cost involved in drilling wells and testing wells and make sure that they will supply what you want. There are some perceived risks about drilling into workings, which I'll talk about shortly. It's low temperature heat, so you do need to put some energy in to upgrade it. So you need to use a heat pump or something to lift the temperatures to make them more usable. Social acceptability, so people have to want this, know it's there, they have to demand it. And we found that from the work we've done with some of the communities close to Durham where we've been working, that people generally are very positive about reusing this infrastructure that was so hard won by many of their kind of family members and other relatives. The mines are still within living memory for a lot of people. They think of the camaraderie and the spirit that was around them. And a lot of people feel that they don't want all of that effort to be wasted. And so we have found some very positive views on using mine water from the work we've done so far. The other con is that retrofitting it can be complex. So a lot of the housing stock, for example, that we have now will still be around in 2050. So we do need to address some of our existing buildings. So we need to think of how we can better retrofit these type of systems, all kinds of low carbon energy systems, not just mine water. So I mentioned before that we need a new approach to heat. So we need to rethink heat as not necessarily being a hot thing. So there's heat in that bottle of water. You certainly wouldn't want to take a shower in anything of that temperature, but we could take a few degrees out of that and lift the temperature to make it more usable. So we don't need to think of heat that's something that we can have as felt warmth to us. So a river, for example, contains plenty of heat. There may be enough heat in a river to heat an adjacent building. And we need to think, why are we doing what we're doing with gas boilers? So this building's probably heated by a gas boiler, which is raising temperatures to 80, 90 degrees or so, and we're heating this room to maybe 20 degrees. So why is this disparity between this kind of extreme temperature to reach this kind of lower temperature that we're wanting the room to be? And if you heat water to a higher temperature, obviously you're going to use more gas and you're going to produce more carbon, which is what this graph shows here. And if you think about circulating water around a heat network, if you can have the temperature lower, so if you can circulate at 40 degrees rather than 80 degrees, you're also reducing the losses in the system. And there's evidence to suggest that that kind of 40-degree difference can lead to 65% reduction in kind of energy lost. So it's well worth thinking about why we need to circulate things at hot temperatures. In order to do this and rethink heat, we also need changes to policy and planning. So we need to have things in building control, and we need a national planning policy that will allow regions to consider mine energy projects when they're doing redevelopments or refurbishments. We need people to know about it and start asking for it. And as I've mentioned before, we need to think about design temperatures. So if we're thinking about switching something to geothermal in future, we need to ensure it's sized adequately to cope with lower temperatures. So I'm just going to kind of talk a little bit now about accessing the resource. So here's a mine plan that we've got for one of the case studies that we've been looking at. And just to address people's concerns about drilling into workings, it's really not something we should be scared of doing. These plans date from some areas are from the 1930s and earlier, and you can see that these little red dots here, it's peppered with boreholes. We've been drilling into mine workings for a long time. There's a lot of expertise there and a lot of experience. The other thing to point out on here is the different types of working that we see when we look at the plans. So these are areas that were worked by longwall mining, where you had kind of wholesale extraction of the entire coal seam with subsidence as you retreat. And then these areas of this kind of cross-hatching here are room and pillar, where you would find that pillars of coal are left and the tunnels in between were taken from coal. And quite often these areas, as has happened here, this was all room and pillar, and they've gone back in and reworked it for longwall at a later date. You often see these little islands as well where nothing has worked, and that's usually the mine manager's house. So it was early NIMBYism. So the way we do this is we get the mine plans. So we'd maybe have, for one area, we'd have workings on several different seams, maybe up to 5 or more. And then we look at the seams we're interested in. We want shallow ones to keep drilling costs down. We want different seams to abstract from and re-inject to. So we've got good flow pathways so the water's not mixing and you're not cooling your source. Then we use the seam thickness to calculate the flow, the heat in place. So we're working out a volume, and we correct for subsidence depending on whether the area was lined by long wall or pillar and room. So there's different correction factors we use for that. Then we can take that forwards to calculate the extractable heat. So this was some work that a master's student did with me, looking at a site adjacent to us. The Coal Authority already pump a considerable quantity of water out here. They pump out around about 200 litres per second to keep water levels static in this area. This water is clean, it has no treatment, and it goes straight into the River Wear and actually improves the quality of the receiving watercourse. And the upshot of the workings here is that there is plenty of heat that could supply 200 new homes that are planned for development in this area. So we've been consulting with developers, local authorities to try and get this type of system piloted. And how it would work, you would have a heat pump at the surface and then a heat network where hot water would be supplied to the homes. So you may have a heat pump in each house, or you may have each home working off a cluster. There's various different configurations depending on the size of the scheme. And you take water out of the workings from a flooded coal seam and you would put them back into another seam, if possible, to avoid mixing of your hot and cold supplies. So some examples, there's one in the Netherlands where 5 wells were drilled into old workings here down to depths of 700 metres. Their system is quite warm, so it's 28 degrees. And they have a big system here of both retrofit and new build and mixed use as well. So there's commercial and residential. There's around about 200,000 square metres of floor area in total is supplied from the mines. And they have a smart system here where it's kind of energy exchange. So buildings exchange energy with each other rather than always going back to the central network. And they put a lot of the rejected heat back into the network. They're also looking to bring other sources of waste heat to inject into it as well. So it's a really interesting project. If you get the opportunity to see it, it's well worth a look. And as I mentioned earlier, this has delivered economic improvement to an area that was a deprived mining area because a lot of people had lost their jobs when the mines closed. And so people are now paying for their energy to a regional organisation, so the money is staying within that region rather than leaving. So the energy spend is kept in the region and used to deliver other social improvements. This is where we've been working with Lanchester Wines. So they have 2 storage facilities. They have 2 warehouses that need to be kept at a controlled temperature to store their wines. And they've been taking a really innovative approach to all of the kind of energy systems for their sites. They have some wind turbines. They're very keen on reducing their carbon emissions and also taking a longer term view on what energy costs might be for their business. And they have seen both the installation of the wind turbines and installation of the heat pumps as an important thing for them to do to keep their business going and to future-proof it. So they have had some problems with some of the drilling. The system is now working and they're very keen to share their expertise and their learnings from this. So hopefully we're hoping to start some program of sharing the information that they've had whilst they've been developing this system. But this has showed that it's possible to do for an industrial setting, which is slightly different to the Heerlen, which has quite a lot of residential. So it's got a range of applications, and this system now works really well and delivers this kind of secure energy future for this company. So my kind of take-home message is I'd be really pleased if when you go away today you just not forget about heat. Remember that heat is as important as electricity. And that in the abandoned mines we have this vast infrastructure for heat supply and storage. We have indigenous and low carbon resource beneath our feet in many areas of the UK. So we're talking about a quarter of UK homes which currently overlie coalfield areas. So there's good potential. And this could deliver a low carbon source of heat in future. We were asked when we put our slides together how we make this happen. So we've got some research questions to think about how we integrate mine energy into other energy networks. What's the opportunity for energy storage? Can we store waste heat as well? And looking at the longevity of systems, we've got systems like the Netherlands one's been running on the scale of decades, but what's the longevity, and what happens if other people start to develop more schemes and the mine workings are connected together? They're highly interconnected systems. So what happens if everybody tomorrow decides they want a mine energy system? How do they impact each other? Barriers are upfront capital cost, risk-averse attitudes to things like worrying about drilling and worrying about water quality. All of these things can be dealt with as long as you know what you're dealing with. Changing the perceptions of heat, so we don't have to think of heat as necessarily as something hot that is felt warmth to us. And I've mentioned already things that we would have for planning policy or regulation. So thinking about mine energy potential for coalfield areas, this needs to be a national policy, so developers are not driven from region to region if they don't want to look at mine energy. We need to get developers more engaged with what this has to offer and the potential to sell energy. And also we need to make changes to building control so that our buildings are more capable of accepting lower temperature heating systems in future. Thank you very much for listening.
Thank you, Charlotte,
Thank
for
you.
a very clear talk. I have to ask, the Lanchester Wines, was that a geothermal cooling project, was it?
It's heating and cooling,
Heating and
so they keep it above ambient. Okay. In the winter, they need to provide heat to it. I think it's about 30 degrees or so.
I'm sure all the lights are connected to geoscience and wine.
Yeah, I'd like to have got some geothermal wine for this evening or something, but.
Oh, Charlotte.
Aye.
Is there a regulation for valuing the heat? What's the law under which you can extract heat from the subsurface?
There's nobody's charging you to abstract the heat. There's various things you have to do. You have to have an abstraction license and a discharge consent from the Environment Agency, which there's a cost associated with depending on how much water you're using. And there's also permission and consents to drill from the Coal Authority and charges associated with that. I don't think we have a very clear licensing scheme at the moment. And I don't think we certainly don't have anything where the heat that you're taking is going to be charged for. I suspect that will happen as schemes develop and the interest grows. I think people will want to start doing that. But
do you think that could be a barrier to entry? Because at the moment you're using a water supply law. Is that right?
Yeah. I mean, we do need some changes there, I think. Because really, if you're putting it back underground where you got it from, you've got to think, why do you need discharge consents? If you're not taking anything away as well, why do you need abstract and discharging? It probably needs to change in form a little bit, I think, to accommodate that. But yes, I mean, the Coal Authority see it as a resource that's very valuable, but at the end of the day, they can't price it too highly because then nobody will use it. So there is kind of a bit of an impasse at the moment as to, who's going to make the first move and what's going to happen.
Can we take
Great presentation. Joe Emmings, British Geological Survey. So the geochemistry of coal and surrounding country rock is going to differ quite substantially from crystalline basement, for example. So I'd imagine the chemistry of that mine water to be quite distinctive. I wondered if you'd be able to expand on that at all. I'm thinking along the lines of particulate and dissolved organics in the water, and also potential for mobilisation of metals.
Mm-hmm. So if you think about mine water, obviously there's a range of qualities. So it's usually classed as being net alkaline or net acidic, depending on the buffering capacity of the host rocks. The thing that causes the biggest problem or perceived problem in some of the mine water systems is iron, which comes out of the parites within the coal seam. So we can know something of the water quality because we can look at the sulfur content of the seam when it was worked. So there's one in Durham, which is a particularly bad customer because it had a lot of sulfur in, and the water quality from that seam is notoriously poor. So whenever that's had to be pumped out, to control water levels, then it almost certainly would need treatment. The thing with the iron is that as long as you keep air out of the system, it won't precipitate. So what they do in the Netherlands is they keep air out of the system, so it doesn't come into contact at all in its journey from the subsurface through a heat exchanger back into the subsurface. And they also keep it under pressure. Just 1 bar of pressure will keep the iron from coming out. Other people have accepted that iron particulates will be there, and they've put in kind of double filtration and double heat exchangers so that they can switch them over if one does become clogged. But it's certainly something you can design around and not something you should be afraid of. There's a lot of treatment technologies for mine water out there.
Can we take just 2 more questions, Councillor?
Malcolm Brown. I'm just wondering how the upfront capital cost works in a small residential thing. Does a developer pay the cost and pass it on in the price of the house? Because the future resident will get cheaper heating, or how does that really work, and what sort of scale of cost is it per house?
Yeah, I mean, it's a really good question. I think it's something that needs to be thought about. And the way we've been thinking about it, I was talking to a heat pump installer yesterday, and I think there really needs to be somebody that's prepared to drill the wells, who would then make their money from drilling the wells back by selling the heat. So I think we probably need some new organisations or new energy companies or existing energy companies that are willing to diversify to drill. I mean, we're saying, for example, should the coal authority drill and then charge a little bit per kilowatt hour? That could be one way of doing it. Or should there be a company come in and say, right, we're going to drill all these wells? You've got this kind of trade-off between you need the end user to lock into your, the load you're going to provide before you've put the money into drilling the well. So these are some of the things we need to negotiate around. But it's, a really good question.
So. Can we take 1 question there and we can let you finish it?
Frances Wall from Camborne School of Mines in Cornwall, where we're a bit challenged on coal mines, but we have loads of old tin mines, and exactly the same applies, of course. They're underneath Camborne Pool Redruth, so the central area where the largest population centre is, and as far as we understand, it would work just as well as the coal mines. So it would really help us when you put up those maps with all the old coal mining areas, if you could just put a little tin mining or something down in the southwest to show everyone.
My PhD was on the metal mines, so I know exactly where you're coming from. I mean, the areas that I was looking at, unfortunately, didn't have the population there. But when we're thinking about areas of fuel poverty, there are often old historic metal mining districts that are linked with fuel poverty, and they're off the gas network. They can be really attractive. I've been doing some work with our local MP, and she's really interested in looking at those areas. So I certainly haven't forgotten. They're definitely on my radar, but not part of today's. But good point. I can put them on for next time.
So
Thank you.
Since you were speaker, we will let you have a little last word. Can you? Okay. Yeah, I think. Okay. Go ahead. A quick one from John, and then I'll let you know.
John Midgley, BGS. I'm technical manager on the UK GEOS projects. One of the projects is in Glasgow. We're drilling into the mine workings. We're facing all kinds of challenges, even from the coal board, around what you can leave in a mining system, just in case they decide to open the mines up again. We found out that our major costs, even though the drilling's very expensive and the drilling contractor's doing very well out of it, we've got major costs around things like water disposal. Because we don't know the accurate chemistry, we're having to plan to dispose of some very nasty acidic waters, and it's driving the project costs through the ceiling. We've drilled one well already in Glasgow where we encountered no mine workings, so you've got to question the veracity of the mine working maps. But the next ones we are guaranteed to hit mine workings because we're directly above the government mines. So keep watching for the reports in the newspapers, the Twitter feed, and everything on the BGS website. Advert over. Thank you very much, Phil.
I was just going to say, we've actually got a geoscientist article coming out that I've written with Alison Monahan, who's leading a lot of that work. So that's actually in review. So it will be coming into Geoscientist, I think, spring, summertime. So. Oh, good. Excellent.
No, it's not a question, but something that one need to think. I encouraged somebody in Basel, in Switzerland, to go for ground heat pump. He rang me up after a year that he was getting 880 Swiss francs from the government for saving CO2. Perhaps we ought to have a mechanism like that in the UK.
I think certainly for the larger schemes, the renewable heat incentive for some of the large geothermal schemes does look very attractive. We've done some sums for the local authority who are thinking of refurbishing a leisure centre, and it's lying on top of mine workings, and it, certainly with that incentive it would pay back the capital within the time frame that they wanted. So yeah, I think we do have that. I think it's probably getting over the risk and things we need to address.